Okay. So here we're going to draw the circuit and we're going to answer the questions. So the circuits are pretty much going to look about the same because it's all in series. So the only thing that's going to change is the number of resistors. So for this one here, we have a 10 ohm resistor, so I'll call that R1. And we have another resistor, that's R2, that's 20 ohms. Okay, and the battery voltage is 15 volts. What is their combined resistance? So that's easy. So the combined resistance is R1 plus R2, so that's 30 ohms. What current flow through the circuit? So in order to do that, you have to combine this resistor. So in other words, you have to turn this into a simple circuit with only one resistor. So V is I times R. Now the I is constant. The V is the V total. That's the battery voltage. This is the total resistance. So this is going to be 15 equals I times 30. So your current is half an amp. Okay. What is the voltage drop across each resistor? Okay, so if you want to find the voltage drop in this one, you do V equals IR again. So I is the same, so I'm just going to leave it with no subscript. So this is just going to be 0.5 times 10, so which is 5 volts. For the other one, you can do it two ways. You can do V equals IR again, or since this is the last one, and you used 5 volts here, this one is going to be, this one is going to be 10 volts. All right, let's look at 35. Okay. All right, so this one I have 20 ohm there, and this one is 100. Okay, and the voltage is 240. All right, what current flows through the circuit? So V total equals I R total. So this is 240 equals I times total resistance is 120. So the current is going to be 2 amps. The drop across each resistor, we do V equals IR. So the current is 2, the resistance is 100, so this is going to be 200 volts. Now to figure out the voltage across this one, you can just do 240 minus 200, or you can just do V equals IR again. So I'll leave that up to you. So this is going to be 2 times 20, which is 40 volts. So 240 should add up to the voltage of the battery. Okay. So now we have a 10 ohm and we have a 15 here. Okay. And we don't know what this voltage is, but all we know, we can probably figure it out. All we know is that there is a current of 0.5 amps going through each one of those. It's one path for the current, so the current has to be the same. What is the voltage drop across each resistor? Well, it just V1 equals I times R1, so that's going to be half times 10, so that's going to be 5 volts. V2 equals I R2, which is 0.5 times 15, which is 7.5 volts. Okay. Now voltage across both resistors is going to be 12.5, and that's the voltage supplied by the battery. Okay. Let's look at 37. Okay. This is a 240 lamp. Okay, so we need to figure out what this resistance is. Okay. Okay, this is 120 volts. This is the current, which is 0.4 amps. Okay. So we're going to do V equals IR. Here they're saying to reduce because without this resistor, the current was greater than 0.4. So if you add a resistor in series, you decrease your current. So this is going to be 120 equals I, which is 0.4, times R2 plus the 240. Okay, so R2, if you solve this equation, I would not distribute. I would divide by 0.4. So and then subtract 240. So it should be 60 ohms. All right, let's look at 38. Okay, this is 8 ohms. The other one is 12. This is 10 volts provided by the battery. Find the power dissipated in the 8 ohm resistor and the voltage across the 12 ohm resistor. So maybe it's not a bad idea to find the total current. V total equals I, R total. So this is 10 equals I times 20. So the current is half an amp. So now we have half an amp going through both resistors. So if you want to find the power dissipated in the 8 ohm, we can just do power is I square R. I don't feel like finding the voltage. So I'm just going to use this formula that doesn't need voltage. So it's going to be 0.5 square times 8. And I think that should be 2 watts. Yeah. Okay. The voltage drop across the 12 ohm, V2 equals I R2. So that's half times 12, which gives us 6 volts. Okay. What is the current through the resistor? Okay, so that's an easy one. So you just do 24 divided by 6, and that should give you, what is that, 4 amps. Okay. If the resistor is replaced with a 12 ohm resistor, how will the current through the circuit change? So if I double the resistance and I leave the voltage constant, the current will have to be cut in half. Okay, so let's look at this one here. In each, rank the magnitude of the potential difference between M and N. Well, M is connected directly to the positive side. N is connected directly to the negative side. There's a gap here in all of them. Well, not this one, but this one, even though you have a light bulb here, M is still connected to the positive, N is still connected to the negative. So the potential difference is the same. So in other words, if you put a voltmeter here, you're going to measure the voltage drop across the battery. And since it's the same battery, we should get the same reading. Okay. For this one here, here you're measuring the voltage of the battery. Here you're also measuring the voltage of the battery, regardless of what's here. Because in all 3 cases, actually, the M is connected to the positive, and all the N's are connected to the negative. So it should be the same. Okay. For this one here, in all cases, we're measuring the voltage drop across one light bulb in all 3 cases. So they should all be the same because all the light bulbs are identical. All right, so this was delivered in the lesson. Okay, let's look at 41. What is the equivalent resistance of the circuit? Now, I'm going to give you a shortcut here. So you have 3 resistors connected in parallel, right? And they have the same value. To find the equivalent, all you have to do is you take one of them and divide it by 3. So this is going to be 1 ohm. If I only had 2 of them, I would just divide by 2. If I have 4, I'll divide by 4. Okay, number 42. 2 resistors are connected to a source of voltage as shown. At which position should an ammeter be placed to measure the current passing only through R1? So you only want to pick up what's going through R1 here. Okay. So the only one that's going to do it, you can put your ammeter either at position 3 or you can put it up here. You only want to get what's going through R1. So 3 is the correct answer. Okay. Now I talked about it, the circuit breaker in the previous video. A certain 20 amp circuit breaker trips when the current in it equals 20 amps or higher basically. What is the maximum number of 100 watt light bulbs you can connect in parallel in an ideal 120 volt DC circuit blah, blah. Okay. So I think we need to figure out maybe, can figure out the current through each light bulb. So we can do P is I V. Okay, so the light bulb is 100 watts equals I times 120. So the I will be 100 divided by 120, which is basically 5/6, it looks like. Yeah, 5/6 amps. So now how many light bulbs do I need? Well, the maximum current that I can reach is 20 amps. So all I have to do is 20 divided by the current going through each light bulb. And that should give me the number of light bulbs that I can use to get up to 20. So I should get, okay, so 20 divided by 5/6. So I get 24 amps. Okay, 24, I'm sorry, bulbs. So at 24 bulbs, the circuit will break, will trip. So, which means I have to go lower than 24. So 23 is the answer. Okay. In which of the circuits below would the ammeter read the least current? Okay. The least current means the least resistance. Okay, so the voltage is all the same. The least current means the highest resistance. Sorry, I was thinking the highest current. So these two will give you a resistance that's less than 5. As a matter of fact, it's going to be 2.5. This is going to be 5/3. This is 5. This one will give you a resistance of 10. So the answer should be 1. All right, let's look at 45. A heater, a toaster, and an iron connected in parallel to a potential difference of 120 volts. So here's your 120. And here are your resistors. So the heater, I'm going to call it R1, toaster R2, and the iron is R3. So this is 120 volts. The heater has 12 ohms, toaster 20 ohms, and the iron 24 ohms. What is the current flowing in each device? Well, I'm going to do V equals IR for each branch. Now the V remains the same at 120, but the current changes. So if I do it for this one, it's V1 R1. So it's 120 equals I1 times 12. So the current in this one here is going to be 10 amps. I do the same thing here. 120, I replace the 12 with 20, so this is going to be 6 amps. And in here, we're going to get 120 divided by 24. Okay, and that should give us 5 amps. Okay. what is the current? Okay, what is the total current? All you have to do is add them up. So the total current is 21 amps. Okay. What is the combined resistance of all three devices? So I can do the 1 over Req is equal to 1 over 12 plus 1 over 20 plus 1 over 24. That's one way. Or I can just do V equals I, total current, equivalent resistance. I can do Ohm's law to a simple circuit where I combine all these three into one. So this is going to be 120 equals 21 times Req, right? So Req is 120 divided by 21, so which is 5.71. Okay. All right, number 46. Here they get telling me that its lamps are 18 watts each, and I have 4 of them. Okay. Voltage of the battery is 6 volts. What is the current in each lamp? So since I'm dealing with power, I can write power equals what are we looking for? Current. So I'm going to do I square times R. That's the one that's going to cut it for me. So 18 equals I square. No, that's I square. We'll do IV. Yeah, P equals IV. That's the easiest one. So 18 equals I times 6. Okay, so the current is just 3 amps. So I'm going to have 3 amps going through each one of this. Okay. What is the resistance of one lamp? Well, I can just do V equals IR for each one of them. The voltage is 6, the I is 3, and I can find the resistance. So the resistance is just 2 ohms. So each one of those is a 2 ohm resistor. Okay. What is the total resistance of the 4 lamps? So each one of them is 2. So I have 4 of them. I just do 2 divided by 4. If I don't feel like doing the 1 over Req business. So I should get half an ohm if I connect all of them together. Okay. All right, here we only have 2 things. So we have a 240 watt lamp, and we have a 12 ohm resistor. The voltage is 120 volts. Okay, what current flows through each? Okay, so to find the current, I can do P equals IV. Okay, for the first one. So this is going to be 240 equals I times 120. So I get I equals 2 amps going through here. So this is going to get 2 amps. For this one, I just do V equals IR. So this is 120 volts equals I times 12. So I is 10 amps. So I'm going to get 10 amps going through here. Okay. What is the combined resistance of the lamp and the heater? So I can do V equals IR. This is total current. This is the equivalent resistance. In other words, if I can replace all of this with one resistor, it will definitely be less than 12. That's for sure. So this is 120 equals total current is looks like it's 12 Req. So the Req should be 10 ohms. So we have a 6 ohm and a 12 ohm, 12 volts. Find the voltage across the 6 ohm resistor. So that's just going to be 12 volts. Okay, and so each one of those is going to get 6 volts. Find the current through the 12 ohm resistor. So I do V equals I R. So I'll call this R2, call this R1. This is I2. So this is going to be 12. They both get in 12 volts. I2 is what we're looking for. This is 12. So the current here is just 1 amp. Find the power dissipated in the 6 ohm resistor. So I think for that one, I just do power is V square over R. So that's going to be 12 square over 6. So what is that going to be? So I can get 12 times 12. I can make this 2 times 6. So it's 24. 24 watts. Okay. Find the thermal energy used in the 12 ohm resistor over 2 minutes. So I think we have to find the power first. Okay. So power for 2 is IV, I guess. So the current here is 1 amp times the voltage is 12. So that should be just 12 watts. And if you want to find the energy, you do 12 watts times 120 seconds. So you get 1440 joules. In your bedroom, you have 2 100-watt lights, a 50-watt color TV, so you can read all the rest here. Okay, and if you have a 15 amp circuit breaker and the voltage in your house, in your outlet is 120 volts, will the circuit breaker trip? So what we need to do here, we need to find the total current. Now P is IV. The total power will just be adding all the powers. And keep in mind that this is 2 hundredths, so that's 2 times 100. So the whole thing adds up to 1750 for the power times I times 120. And if you do the current here, you're going to get 1458 amps, which is less than 15 amps, which means the circuit breaker does not trip. Okay, number 50 is conceptual. As more lamps are connected in series, the current will decrease because now you have more resistance for the same voltage, so the current has to decrease. Okay, 51. As more lamps are connected in parallel, the current will increase. Now you're giving more pathways to the current to flow. We talked about all this stuff. Okay, number 52. Okay, so we're looking for the total power. Now all these setups have the same V. So I think I'm going to use the power equals V squared over R formula. Okay, so the V is constant. I just have to compare the power based on the resistance. So the resistance here is just R. It's 1 light bulb. In here, it's 2R because you have 2 light bulbs. And here you have R and R in parallel. That should give you half of R as the equivalent resistance. So the one that's going to have the least power is the one that's going to have the more resistance. So the ranking should be B, A, then C. Number 53, I'm going to redraw it so that it's easier to see. So I'm going to put R1 here, and that's 5.6 ohms. And I'm going to put R3 here, and that's 14 ohms. And I'm going to throw in the R2 here, and that's 5.6 ohms. And the voltage of the battery is 6 volts. What is the equivalent resistance? Okay, so this is a complex circuit. So the way to do this, you have to see that these two here, R2 and R3, are in parallel to each other, right? And the reason for that is because they share the same voltage. The circle points are identical, these axes are identical. So we have to find the equivalent of these two in parallel. And this R1 will be in series of the combination that comes out of these two. So this is 5.6 ohms, that's R1. And this is the equivalent of the other two, which ends up being 4 ohms. Okay, and this is still 6 volts. So the equivalent of the whole thing is 5.6 plus 4, so that's 9.6 ohms. Find the current through each resistor. So now we're going to work backwards. Okay, we're going to find the current in the whole thing. Okay, we're basically going through each resistor, and that current is going to be 6 divided by 9.6, which is 0.625 amps. So now we have 0.625 amps going through, not amps, not volts, amps going through here. And then we have 0.625 amps going through the 4 ohm resistor. So basically what it means is that the 0.625 is split between the R2 and R3, not equally. The 5.6 is going to allow more current because it has less resistance and they share the same voltage. So let's figure out what the voltage is. To figure out the voltage here, you multiply current and resistance. And the voltage there will be 2.5 volts. Which means you have 2.5 volts across this R3, and you have 2.5 volts across the 5.6. So to find the current going through R3, you do voltage divided by resistance. So 2.5 divided by 14 should give us 0.45 amps. And then you do the same thing here. You do 2.5 divided by 5.6, and we should get no, the 0.45 is here. This is 0.18. Okay, I had them reversed. Let's look at this conceptual stuff. So this one we have to compare the brightness. So which means we have to compare the powers. And I don't have much information about the current, but I see a lot of batteries here. So I think I'm going to use the formula P equals V squared over R. Okay, and compare them based on that. Now in the first case, you have the voltage of one battery divided by one resistor. In here, you have two batteries, right? So the voltage will be 2V squared over, you have 1R, because you have one light bulb. So basically, in all cases, you have one light bulb. So the R is basically the same. In here, you have 3V squared over 1R. And here, you only have V squared over R. And here, you have also V squared over R, because the voltage across that light bulb is just V. Okay? All right, so if you rank them here, which one is the greatest? So I'm going to get rid of these R's. Okay. So it looks like it's C, then B, then A, D, and E are tied for the last place. All right, let's look at RT7. All right, so if we're looking at the current here, this is an ammeter that's placed in a series circuit, and you have 3 light bulbs, which means the resistance is constant. The voltage is provided by the battery, which means the voltage is constant. So which means the ammeter will have the same reading no matter where you place it, because there's only one path for the current, so they are all the same. for the next one, we only measuring the current going through one of the resistors. And all these resistors, all these light bulbs share the same voltage. And they have identical resistance. So current is V over R. The V is the same for all of them because of the parallel setup. The resistance is the same because they are identical. So they have to have the same current, basically. So the current that each one of them gets is a third of the total current, because you have three branches here. Okay. Here we're looking for the voltage. Okay. We're looking for the voltage between point M and N. Well, the voltage here is basically the voltage of the battery, because you only have one light bulb taking up all that voltage. The voltage between these 2 points here is the voltage drop across this light bulb, which is half the voltage of the battery, because these two are identical. In here, the voltage across there is 1/3 of the voltage of the battery. So the ranking should be A, B, and C. Okay. The next one should be pretty straightforward here. So here the voltage across each light bulb is just the voltage of the battery because of their parallel setup. Okay, so now we're looking for the resistance. So the resistance here is 2R. The resistance here, since they are in parallel, is half of R. If I call R the resistance of each, this is 3R. This here is 1/3 of R. In here you have 2R, and in here you have 1/2 of R. So the highest resistance looks like it's C, then comes A, and A and E are together. And then we have B and F together, and then we have D by itself. Okay, RT10. Okay. Now we're looking for the current. Okay, so now here you have the voltage is the voltage of the battery. So now we have to see, okay, we have to see how many resistors, because current is V over R. The V is the same for all of them. So we're gonna rank this based on R. So the smaller the R, the higher the current. So here you have two resistors in series, so the resistance is 2R. Here you have two resistors in parallel, half of R, and this is 2R, okay? So the one that's going to have the highest current looks like it's B, and then A and C are equal and last. Okay. For the next one, if you look at this circuit here, so let's say the current comes from here, it gets to this junction, it has to split. So all your current will go through this wire here because it offers almost virtually no resistance, right? So these two light bulbs will be off. This is what we call a short in electricity. So you short in these two light bulbs, they don't get anything. So basically here you have one resistor, okay? So I is V over 1R basically, okay? In here, the current comes here, you bypass this one. So this is kind of like your circuit. This gets shorted. So the voltage, the current is voltage over, now you're dealing with two R's. And here, the current comes from here, it follows this path, it follows the path of least resistance. So you have 1R to deal with here. So it's V1 over 1R. So which one is going to allow more current, it looks like A and C come first, and they are tied, and then B is gonna allow the least amount of current. Okay. Now trying to find the current here. In here you have two resistors. V over 2R. That's your, okay, I'll just write it here. This is V over 2R. In here you only have the current going through, maybe I could do this conceptually, and let's see. This is the current going through two resistors. This is the current going through one of the resistors. Okay, I'll do V over 2R. This is V over just 1R. The voltage is the same as the voltage of the battery. Here it's V over, you have three resistors. Here is V over just 1R, because you're only looking at this branch, and the V here is the V of the battery. In here, it's going to be V over 2R, and this one is going to be parallel. So if you turn it around, you're going to see that it's parallel. So this is going to be V over just 1R. So the ranking, the highest one will be B, D, and F, it looks like. Yeah, B, D, F. Oh, this okay. This one is no. This one is V over half of R. Yeah, half of R. So that's gonna come first, because it's got the smallest resistance. So this is F. So this is done. Then come B and D. Okay, and then comes A and E, and then C is in last. Okay. Now we're looking for the voltage. Okay. So if the voltage provided by the battery is V, the voltage from here to here is just going to be half of V. Okay. The voltage here is between this point and this point is just going to be the voltage of the battery. From here to here, if the voltage here is V, and you have three of them, from here to here, you're looking at two resistors between these 2 points. Okay? So 2/3 of your voltage is going to be spent here. So this is 2/3 of V. In here, this is just the voltage of the battery because of the hookup. So this is parallel circuit. From here to here, okay, you're going to get, if the voltage of the battery is V, each one of these two will get half the voltage of the battery. So this is going to be half of V. And for this one here, between this point and this point here is the same thing as between this point basically and this point. So that's just going to be the voltage of the battery. So the highest voltage should be D, B, and F. They all have a voltage of V. Then comes C, and then A and E last. Okay. So these all these resistors are 700 ohms. So 700, 700, 700, and 700. Okay. Now, these two are in parallel to each other because they share the same voltage. So the combination of those two is 350. You can just take half because they are identical. These two share the same voltage also. So the combination of these two is 350. Now, this 350 and this 350 are in series with respect to each other. So it's kind of like, it looks like this. Okay, 350 in series with 350. Okay, so if you see that the current splits, the two resistors are not in series. If the current stays the same, in other words, if there is only one path, then you just add up the resistors. So the answer should be 700. All right, so we're trying to find the equivalent resistance of this whole circuit. So I can see these 2, 2, 4, 2, and 2 are in series. They're going to get the same current. But they are not in series with the 6 because the 6 is going to be getting a different current. So let's say the current is coming this way. It's going to split. Okay, these guys, I'll do it in different colors. All these guys here will get the same current. But the 6 will get a different current. So when this red and blue arrows come together, you'll get what you started with. So on this side here, you got a 4 and 4, 8, 10, 12. So it looks like this. We have a 6 here. We have a 12 next to it. We have a 2 and a 2. Okay. Now these 6 and these 12 are in parallel to each other, right? So a 6 and a 12 in parallel gives us a 4. So now I can replace that with a 4 and the other 2s, right? So the combination should be 8, it looks like, right? So, because those are in series now. Okay. I'm going to redraw this one so to make it look simpler. Okay, that's better. So this is 6 volts. This is a 4, this is a 2, 3, and a 3. So I'm going to simplify this more. So it's going to look like this. Okay, so I have a 6 here and a 6 here, and 6 volts. So a 6 and a 6 in parallel will give me a 3. So this is 3 ohms, this is 6 volts, which means the current is 2 amps, which means the drop across this 3 ohm, it's 2 times 3, which is 6 volts. Now this 3 ohm is the 6 and the 6 in parallel, which means they each get in 6 volts each. Okay, which means the current going through each one of them is 1 amp. And we could have done that without finding the voltage because you have 2 amps coming here and these 2 resistors are the same, so the 2 has to split evenly between the 2. All right, so now we have 1 amp going through here, 1 amp here, 1 amp and 1 amp. So if we want to find the potential difference between B and C, which is right here, okay, it's just 3 ohms times 1 amp, that's 3 volts. Okay. So now we're trying to figure out the current going through this 4 ohm resistor. So I'm going to redraw this. All right, this is 6 ohms, and this is 12 ohms, okay? Now the total current is 2 amps. So now we have 2 amps coming here, okay? And these resistors are in a ratio of 1 to 2, so which means one of them is going to take 1/3 of the current and the other one is going to take 2/3 because you have 3 parts. So this one is the smaller resistance, so the current is going to be 2 times, well, 2/3 of 2. Okay, so that's going to be 4/3. Yep. So that's going to be 4/3 of an amp. I hope you can see that. The least the smaller resistance will get twice the current of the the one that's double. So this is 4/3 of an amp, and this is going to be 1/3 of 2, so it's going to be 2/3 of an amp. If you add them together, you should get 2 amps. Okay, so now we have 4/3 of an amp going through the 6 ohm, so you have 4/3 of an amp going through the 4 ohms, because the 2 and the 4 make up the 6 and they are in series. I'm going to try to find the current in this 2 ohm resistor here. So I'm going to redraw this to look like something we always do. So I'm just going to put the battery on top, and I'm going to have okay, so this branch is down here, okay, and this one stays down there. So you have a 2 and a 6 in parallel. So if you do the formula for resistors, you should be able to find the equivalent of those two. I'll just take out my calculator. So on the calculator, you don't do 1/2 and 1/6. You just do 2 - 1 plus 6 - 1. And that answer is 1/Req. So you have to flip that. So just x -1 that, and that should give us 1.5 ohms here. An 8 and a 16, so let's see what is that going to give us. 8 - 1 plus 16 - 1, flip that, oops. 8 - 1 plus 16 - 1, we're going to flip that. This should give us 5.33, and this is a 2, let's say 2 or 20. Oh, that's a 20, okay. And this is 20. Now we're going to go one more step. Okay, so this is 25.33, and this is 1.5. Yep, that's what I have here, okay. All right, the current going through the 8 ohm is, we have 0.5 of an amp going through here. Now, 8 ohms is half of 16, so it's going to allow twice the current. So through the 16, you get 1/4 of an amp. Okay, now we can figure out the voltage drop across the both of them, which is the same, right? So that should be 4 volts. Okay, now 0.5 and 0.25, that should be 0.75. So 0.75 amps is going through the 20 ohms, which means it's a voltage drop of 15 volts. So in other words, we just do 20 times 0.75. So which means the drop across this whole thing, or which is equivalent to the voltage of the battery, is 19 volts. So this battery is providing 19 volts. Now you have 19 volts across the 6, and you have 19 volts across the 2. I didn't have to do all that stuff. Okay, so to find the current through the 2 ohm resistor, you just do 19 divided by 2, and we should get 9.5. Yeah, almost there. Okay, so we have this setup here. If we close this switch, this light will come on, right? So the light was off in the beginning, so the brightness has to go up. When the switch is closed, does the current in the battery increase, decrease, or remain the same? So this is where it gets tricky. So if we close the switch, so now before you had a resistor, and a resistor. So you have 3 R. Okay, if you close the switch, the B and the C are in parallel now, right? So now, which means the resistance of that combination is less than R, is less than what you had when you only had the light bulb B, which means now the overall resistance is less than 3R, which means the current has to go up. So the current increases here. Okay. When the switch is closed, does the brightness of bulb A increase, decrease, or remain the same? Well, if the current increases, so I'm going to do power is I squared times R. I'm doing here. Okay. The resistance of light bulb A did not change, but the current going through A increased. So the power should increase. So it's going to get brighter. Okay. When the switch is closed, is bulb D brighter than bulb A, dimmer, or, well, it should be the same brightness because they are identical, which means the resistance is the same, and they get in the same current. So the current goes through A, splits, comes back, the same through D. Okay, I'm looking at E. When the switch is closed, does the brightness of bulb D increase, decrease, or remain the same? It's going to increase, just like it's identical to case A. I mean to light bulb A. Okay. When the switch is closed, does the brightness of bulb B increase, decrease, or remain the same? That's the tricky one. The light. So let's do some reasoning here. So now, if the current here increases in A and in D, it means the voltage in A also increased. V equals IR. The R stays the same. The I goes up, so the V goes up, and the V goes up here. Okay. Now you only have 24 volts to work with. So if the voltage in A across A and the voltage across D both go up, the voltage across B has to go down. Okay. So if the voltage across B goes down, now you have P equals V squared over R. The R remains constant, but the voltage dropped, got lower, so the power drops, which means light bulb B will be dimmer, so the brightness will be less. Well, the current here is going to be the same. Just because we moved the location of the resistor, it doesn't mean anything. So here you have the current going through R1. It's going to split and it's going to come back. Well, here it's just going to go, the current is going through here. It's going to split and it's going to come back through R1. So the position of R1 does not matter. So the current should be the same. All right? See you later.